Welcome back, everyone. Today we'll be focusing on trigonometry 1, which have to do with the sine rule. But before I start, I want to explain what an angle is using an acute what? Right angle triangle. If I have this as a triangle and this extended, and I have here as O, and let me say this P, this M, and this X. You can see that this angle at O here is an acute angle. Because acute angles are angles that are what? Less than 90 degrees. Angle M is what? A right angle, which is 90 degrees. So angle P plus angle M will add up to give me 90 degrees because sum of angle in a triangle is 180 degrees. My aim of this topic actually is to treat sine rule, cosine rule, their application, and to treat bearing and distance to a great extent. But before I enter into bearing, we won't be able to do much without understanding some information about a triangle. So we'll start with an acute angle in a right angle triangle. If this is my OP and this is my M and I'm focusing on O, I will have sine of O to be equals to, sine is generally opposite over what? Hypotenuse. That will simply give me what? MP, which is the opposite here. The right angle, where the right angle is facing is my hypotenuse, and the last side is my what? Adjacent side. Where the right angle is facing is the hypotenuse. There is no defined way to know opposite and adjacent, except an angle aside this right angle is defined. So this is defined. Since this angle O is defined here, meaning it was put, this will become my opposite and the third side will become my adjacent. If this is not put, I won't know which is my opposite and which is my adjacent. Because if I have my angle here, that simply means this become my opposite and the third side become my what? Adjacent. So in this case, I'm taking this as my angle. So sine O will be equals to opposite of hypotenuse, which is what? Opposite is my what? MP, and my hypotenuse is what? OP. And my cos O will be what? Adjacent over hypotenuse, which is what? Adjacent over what? Hypotenuse. And my adjacent here is simply what? OM. And my hypotenuse is what? Still OP. And my tan is equals to what? Opposite over what? Adjacent. And my opposite here remains what? NP. And my adjacent remains what? OM. Tan can be gotten in another way. Because tan generally is what? Sine over what? Cos. And I'm talking about O. So it becomes sine O over cos what? O. And sine here is what? NP over what? OP. All over. Cos is what? My cos is what? OM over what? OP. So if I should solve, I will have tan O to be equals to MP over OP. Change my division to multiplication and interchange these two to give me what? OP over what? OM. OP can cancel OP and I have my tan O to be equals to what? MP over what? OM. Just like I got here. So this is what we're talking about here is angles in a right angle which are what? Acute and how they are formed. Now, what if I choose to allow OM here? If I allow OX rather, to be fixed and OP to move. If OP moves, OP will get to a stage whereby it will be greater than what? A right angle, which is 90 degrees. And it will be difficult for us to get the trigonometry of it. And that's why we are going to be treating quadrants, which have to do with the first, second, third, and what? Fourth quadrant. Because we can see that OP now is greater than what? An acute angle. At this position is already what? an obtuse angle, which is an angle greater than what? 90 degrees. So let's see how we can use our trigonometric ratio, which is our sine, cosine, our fourth, second, third, and fourth quadrant, to get angles which are greater than what? 90 degrees. So talking about the quadrants, if we have this, if we are focusing in the clockwise, in the positive angle, then we must move in the clockwise what? Anti-clockwise what direction for positive angles. If it is coming this way, then you know that we are treating what? Negative what? Angles. So we are focusing on positive angles for now. If this is 0, then here should be what? 90, here should be what? 180, here should be 270, and here also becomes what? 360 what? Degree. Now, this happens to be positive, and it carries what? A. You come down, this become what? Positive as well, but you have here as what? C. So if I do this, you can use this to, you can spell the word CAST, since you've known that this is the first quadrant. This is the first quadrant. And you've put C here, and you move to this side. If this is the first quadrant, this becomes what? The second what? Quadrant. This becomes the third quadrant. Since we are moving this way, this becomes the fourth what? Quadrant. If here is C, this becomes what? A. This become X. This become what? C. And this become what? X. Meaning, I get my first, second, third, and fourth quadrant, moving it in a clockwise direction using the right angle we just drew. Is A. And for the first, this becomes second using the what? Anti-clockwise direction. This is third, and this is the what? Fourth. Now, if I want to distribute this A, C, C, X, I will still start from my A, which is the first quadrant, but I will now move in the anti-clockwise direction to spell the word acts, which is just like act of the word apostles. You understand? A, C, T, S. Some people can put A here, put C here, and spell forward. Cast, C-A-S-T. It's a matter of how you understand it, but using acts to be easier. But your first quadrant is your right angle you are seeing here. Since you are moving in the what? In anti-clockwise direction for positive angles, you have first quadrant, you have second quadrant, you have third, and you have what? Fourth. And after that, you move in the anti-clockwise direction, which is just like negative angles. You now spell what? Acts. So for the quadrants, you use what? Your anti-clockwise direction, and for the what? For the spelling, you use what? Clockwise what? Direction, which is for what? Negative what? Angles. So if we spell this, what you have to do now is this. The A here simply implies that all the functions are positive. And when I say functions, I mean sine, cosine, and what? Tangent. The three functions for the first quadrant are what? Positive. Now for the second quadrant, you can see X. You see X standing here simply means only sine is positive. That simply implies that cosine and tangent in the second quadrant are negative. And for the third quadrant, we have tan. Yeah. So therefore, it's only tan that is positive. Meaning sine and cosine are negative on the third quadrant. And on the fourth quadrant, we have C. Meaning only cosine is positive on the fourth quadrant. That's to say, sine and tan are what? Negative on the fourth quadrant. Now let's see how we can use it. Now if this is the first quadrant, remember we must have sine theta, cos theta, and what? Tan theta. In the first quadrant, they are all positive, right? Look at it. And the first quadrant, the angles must be within 90 degrees. For the first quadrant, that has to say our theta will be greater than what? 90. Theta will be greater than 0 degree, and theta also will be what? Less than what? 90 degree. Combining this inequality, remember, you have to have the smaller value first. 0 degree, 90 is greater than 0 degree. So you have 0 degree. Since this, you are putting 0 degree first, your greater than become negative and lesser than. You have your theta, and this already this way. You simply put less than what? 90 degree. So for our first quadrant, we have 0 degree to be less than theta, less than 90 what? Degree. So everything revolves around 0 and what? 0 to what? 0 to, it's 9.99. But it can be what? Exactly 90. Take note. So for the first quadrant, they are all positive. I'll put my positive here. So I'll therefore have what? Sine theta to be equals to what? Cos theta. For the second quadrant, I'll have cos theta to be equals to plus what? Sine theta rather equals to what? Plus sine theta. Cos theta will be equals to what? Plus cos theta. And tan theta will be given plus what? Tan what? Theta. So this is for the first quadrant. For the second quadrant, we have theta to be greater than what? 90 degree, and theta to be less than what? 180 degree. You don't need to grab it. This is what? This is the second quadrant. You can see any angle that exceeded here will be greater than 90, but it will be less than what? 180. So therefore, combining this inequality, I'll have 90 degree to be less than what? Theta, less than what? 180 what? Degree. Now, I have sine theta, cos theta, and what? Tan what? Theta. So for our second quadrant, remember what is only positive here is what? Sine. So here we mean sine plus sine. Here we call minus cos. Here we call minus what? Tan. And you put your brackets. Since we are talking about 180 degree and 90 degree, here become what? Theta minus what? 180 what? Rather, this becomes, since IS is 180, we have 180 degree minus what? Theta. And we also have 180 degree minus theta. And lastly, 180 degree minus what? Theta. Why are we saying 180 minus theta? Because any angle here must be greater than 90, will be less than theta. So you simply have 180 minus what? Theta. Now for the third quadrant, or let's use here, or let me wipe this. So for the third quadrant, we simply have it as theta is greater than what? 180 degree. And theta is what? Less than what? 270 what? Degree. So combining the inequality, since 270 is greater than 180, 180 must come first. So we have 180 degree. Theta is greater than 180 degree, meaning 180 degree is less than what? Theta. So I'll put my less than what? 270 degree. So in the third quadrant, we have 180 degree to be less than theta, less than what? 270 degree. Now, we still have our sine theta, cos theta, and what? Tan theta. Now, for the third quadrant, you see that what is positive is only what? Tan, because tan is what's showing there. So here become positive, and the remaining two become negative, negative. You still put your sine, your cos, and your what? Tan. Now, for this case, you can see that theta must be greater than 180. So what you simply do here, instead of 180 minus theta, like in your second quadrant, which we just erased, we simply have what? Theta minus what? 180 what? Degree. Bracket theta minus 180 what? Degree. Bracket theta minus what? 180 what? Degree. And for the fourth quadrant, we simply have, you can see it, theta must be greater, fourth quadrant, for this 270. Theta must be greater than 270. It can be 271, it can even be 270.1, but it must be greater than 270. So theta will be greater than 270 degree, but theta at the same time must be less than what? 360 what? Degree. Take note. Now, we therefore have our fourth quadrant as combined inequality to give us 270 degree to be less than theta, less than 360 what? Degree. Now we have our what? Sine theta, cos theta, and what? Tan theta to be equals to, well, the only thing positive there is cos. That's why C is showing. So we have plus cos, and we have minus what? Sine, and we have minus what? Tan in brackets. Now what we are using here is 360 because theta must be greater than 270. So we simply use 360. We have 360 degree minus the value of theta, which must be greater than 270. So we have 360 degree again minus what? Theta, and 360 degree minus what? Theta. So this is the relationship of sine, cosine, and tangent from the first to the fourth what? Quadrant. Now, how do we even apply this? This is how I'll just do a short explanation on the application. Now, if for instance you are told that sine of, let me say, 300 degree. First, you check where 300 degree fall on. First, second, third. Since theta is greater than 270, it means it falls on the what? Fourth quadrant. Now, using the fourth quadrant, 300 degree should be this, and it's positive, so it must move in the anti-clockwise what? Direction. Sine 300 degree. So from here to here is what? 300 degree. So what will be left here? What will be left here will be what? 60 what? Degree. Take note. Now, since this is on the fourth quadrant and cos is what? Positive in the fourth quadrant, I'm focusing on what? Cos. So I simply have, okay, I'm talking about tan. So tan is negative on the what? Fourth quadrant, since cos is showing. So I simply have tan to be negative sine. This value will be negative sine of, open brackets, my 360 degree, just like we have here, minus the theta. My theta here is this. Because if you use this relationship, you have sine theta equals to minus sine, open bracket, 360 degree minus what? Theta. So I'm using 300 degree to represent my theta. So here become what? 300 what? Degree. So you see that sine 300 degree rather should be equals to minus sine 360 degree minus 300 degree will give you your 60, just like we have here. So we have what? 60 degree. And sine 300 degree, therefore, will be equals to minus sine 30. If this is a right angle, I have 1 here, I have 2 here. If I solve this, I'll have here to be root 3. Why? This hypotenuse side will give me what? Square root of 1 square plus what? 2 square, giving me what? Square root of 1 plus what? 2 square. 1 square. This is 1 square plus what? 2 square, yes. Giving me 1 plus this, giving me 1 plus what? 4. Giving me what? Root 5. No, this is not root 5. This is supposed to be root 3. If this is 1, if this is 30 degree, this will give me 1, and this will give me what? 2. And this will give me what? Root 3 if solved. Now, how do I get it? Sine 60 is equals to cos 30. And sine 60 is 0.5, which equals 1 over 2. Sine 30 rather. Sine 30 is equals to what? 0.5, which equals to 1 over 2. And sine 60 is what? Root 3 over what? 2. So I'm focusing on what? 60. So I simply have what? Sine 60 become what? Root 3 over 2. So this become minus what? Root sine 60, which is what? Root 3 over 2. And this is my answer in short form. If we are to check, we simply have sine of 300. Sine of 300, which gives me minus 0.8660. And if I have minus square root of 3 divided by 2, I'll still have minus 0.8666 what? 0. So this is the relationship of how you can use the quadrant to get both positive and even what? Negative what? Angles. So I'll be moving to Pythagoras theorem because my aim is to treat bearing and distance. But I can't do that without understanding what I just did, my sine, because when you are doing bearing, there are some angles that you will see that you have two angles. How do you choose the angle that is correct for that question matters. And some questions can be what? Can give ambiguous angle, whereby you have more than one angle. How do you know the angle is correct? How do you know the angle, the triangle form can be with respect to what? Two what? Different triangles. That's why I'm starting from this what? Aspect. So from this, I'm moving to what? Pythagoras theorem. So we have our Pythagoras theorem here. But before we do that, this is a right angle triangle. And like I said, this is my hypotenuse side. Let me use H. I won't know my opposite side. And if I have this angle here, here become my what? Opposite. And here become my adjacent. But if I still have this is still my hypotenuse. If I put my angle here, here become my opposite. And the third side become my what? Adjacent. So it's not what you cram. If we put two angles here, and here is A, here is B, and here is C. If they say sine A, then here's my opposite. Oh, let me not confuse anybody. Let me put another triangle. If I have this, and this is an angle, this is an angle, and I have here as A, B, C. If I say sine C, if I'm talking about C, here is my opposite. Why? C is facing this way. This remain my hypotenuse, and here become my adjacent. Sine C here will simply be what? AB, which is opposite. Opposite over what? Hypotenuse. And sine remain opposite over hypotenuse. And my opposite for C is what? AB. And my hypotenuse remain what? AC. If I focus on sine A, my A this time, here will be my what? The same opposite of hypotenuse, remember. My A here, my opposite here will be what? For sine A. My opposite will be what? BC. And my hypotenuse remain what? AC. So please take note how to get your opposite and your adjacent what? Side. Still on the Pythagoras theorem, if this is my hypotenuse, and this is my, let me say I'm using this angle, this becomes my opposite and this is my adjacent. We should know that the square of this hypotenuse side, H square, will be equals to what? Adjacent square plus opposite square. This is what? A theorem. Hypotenuse square is equals to adjacent square plus opposite square. Why am I bringing it? Because sometimes in bearing, we can get a triangle whereby two sides are known, and the angle, one of the angles between them is a right angle triangle. We simply use what? Pythagoras theorem instead of using sine or cosine rule to resolve it. Because we use sine and cosine rule when the angle is not a right angle what? Triangle. You can also use cosine rule because cos 90 will simply give you what? 0, and it will bluff out some part of the what? Cosine what? Rule. So focus on this. We can get, if I have my hypotenuse side, I can adjacent side, I can easily get my opposite side. Meaning if I have any two sides, the third side can be known using Pythagoras what? Theorem. Now, if for instance, I have this triangle, and I have here to be, let me say I have here to be 3, and I have here to be 4, and I'm looking for x. We should understand that with this, I must define my sides. This is my hypotenuse, so x happens to be hypotenuse. This is 3, this is 4. Always an adjacent here does not what? Matter. Now my x is my hypotenuse, so I must have s square equals to what? 3 square plus what? 4 square. The sum of the two, and this is hypotenuse, just like this. Now I have s squared equals to 3 squared is 9 plus 4 squared is 16. Or I have s squared to be equal to 4 plus 16, 9 plus 16 rather, gives me 25. And I have x squared to be equals to plus minus the square root of what? 25. Same square root. This we cancel this, and I have x to be equals to plus minus what? 5. But triangle, the side of a triangle can never be negative, so my s is positive what? 5 units. Units because the, what's it called? The unit is not given, so you use units. So my x here happens to be what? 5. Also, we can equally be giving a side and one of the what? Angle. If we are given a side and one of the angle, we can simply use a rule called what? Socatoire. If this is it, and let me say here is what? Here is 60 degrees. And I know one of my side, let me say here is what? Let me say here is 4 meter. Let me use 4 meter this time. I can say this A, this B, and this C. So this is a triangle, a right angle triangle at C, and angle B is what? 60 degrees. Remember, if B is 60 degrees, this angle is not given, but these two angles must sum up to give you what? 90 degrees. So if these two must sum up to give you 90 degrees, therefore A will be what? 90 minus 60, which gives you what? 30 degrees. I don't want to put it here to avoid confusion. Now, if this is 60 degrees, that simply means that if I want to get this side and this side, I can. Because I've used sum of angle of a triangle already to get my angle A. And if you see 30, 60, 90 gives you sum of angle, which is what? 180 degrees, irrespective of the type of triangle. Be it isosceles triangle, which have two sides equal and equally two angles equal. Be it an oblique triangle that have none of the angle to be equal to 90 degrees. No, that has no right angle, and so on and so forth. The sum of the angle remains what? 180 degrees. Now, I can get this, and I can equally get this. Let me take this as x, and take this as what? Y. To get my x, using what? Socatoire. This simply means my sine whatsoever, this 60 degrees, I'm focusing on 60 degrees, will be equals to what? Opposite over what? Hypotenuse. And my opposite here, using this angle, is what? Opposite is what? Y. And my what? Hypotenuse is given as what? 4. So therefore, since hypotenuse is given and I want to know my opposite side, I relate it to what? Sine. And sine 60 is what? Root 3 over what? 2 will be equals to what? Y over what? 4. You can see that I can simply have what? Root 3 equals to y over 2y. 2 cancelling 4. You have 2. If I cross multiply, I'll have my y to be equals to what? 2 root what? 3 as my what? Answer. Units. 2 is already greater than 1, so it must carry plural x, which is plural units. Now, we've done that. We can equally get our x. How do we get our x? S has to do there with what? S has to do with what? Cosine. That side there is cosine. So if S has to do with adjacent rather, this adjacent, this opposite, hypotenuse, and this what? Adjacent. Now, if I want to get my S, I'll relate it with cos, because hypotenuse is known, and I want to get the adjacent side, which is x. So I'll have cos 60 degrees to be equals to what? Adjacent over what? Hypotenuse. And my adjacent there happens to be what? X. And my hypotenuse happens to be what? 4. So I'll have cos 60 is what? 1 over 2. It equals sine 30. Equal x over what? 4. 2 here 1 and 2 here is 2. X over what? 2. Cross multiply, I'll have x to be equals to what? 2. And this is my answer. So you see that y is greater than x here. So my y is 2 root 3 units, and my x is what? 2 what? Units. That's it. That's to say, in a right angle triangle, you can use Socatoire to get some side and some angle. You can equally use Pythagoras theorem. If these 2 units, let's check. What's our y? Our y is 2 root 3. Our hypotenuse side is greater, which is 4. And y is what? Already solved, 2 root 3. 2 root 3. Let's assume we don't want to use cos as a function. We want to get our what? X. Hypotenuse, 4 square, must be equals to 2 root 2. 2 root 3 rather, close bracket square, plus what? S square. I'm looking for x. So 4 square is what? 16. Equals to 2 root 3 square will give me 2 square root 3 what? Square. Plus what? S square. This will give me 16. 2 square is what? 4. And square will cancel square root to give me 4 times what? 3. Equals to what? S square. Plus S square rather. Now, I will have 16. 4 times 3 will give me what? 12. Equals to what? 12 plus what? S square. S is already positive here, so let it remain at my right hand side. So I have 16 minus what? 12 equals to what? X square by collecting like terms. 16 minus 12 will give me what? 4 equal to S square. Now I need my S. I'll take the square root from both sides. And my S will be positive 2. Why? A side must be what? Positive 2 what? Units. Just like I got here using my what? Cosine what? Function. So that's it. I'm done with what? The quadratic, the first to fourth quadrant. I've equally done the Pythagoras what? Theorem. Using what? Right angle to get opposite adjacent and hypotenuse. And I've also used what? The Socrates what? Principle to get the unknown what? Side. So what I'm doing next is to prove my sine what? My sine rule.